Hi, everyone. My name is Archita, and I'm currently pursuing a bachelor's in computer science at the Simon Fraser University. And fortunately, this semester, I had the opportunity to work as an applied AI project management intern at Vector. Now, throughout the semester, I've had the opportunity to work in various projects. However, one particular project that I wanted to focus on for the purpose of this presentation was the Applied Research Collaboration Project, which was titled Uncovering Bias in Language Models. So moving to the next slide. Now, before I get started, let's talk a little bit about what exactly was this Applied Research Collaboration Project. Uncovering Bias in Language Models was essentially a project that aimed at facilitating research collaboration on identifying different dimensions of biases in language models and exploring the fairness aspect of it to develop more equitable and ethical language models. Now, throughout the Applied Research Collaboration Project, we had 20 project participants, 8 teams participated, and 6 teams participated, and we had around 5 sponsors as well as fast lane companies. Now, this included TELUS, the Royal Bank of Canada, Scotiabank, Sigma Red, as well as EY. Now, one specific thing about the project that I particularly found very interesting and unique was that every single team in the project were supposed to collaborate with Vector AI engineering team as well as the Vector researchers. They also had the opportunity to explore 2 to 3 potential research directions proposed by the Vector team. They also had the chance to contribute to both the research as well as the application aspects of the project. And the final outcome of the project was to create a benchmark data set, an open source code, or launch or release a project as well as a technical report. So now when we talk about different dimensions of biases, what does bias really mean? Now, bias in this context could refer to the unfair and often harmful favoritism or prejudice towards a particular group, person, or idea. Now, speaking about bias, let's look at some of the examples that can take place in social media, healthcare, or job hiring. Now, bias could be explicit as well as implicit. One of the possible examples, like for example, in social media, explicit bias could be something like people over 60 should not be allowed to vote because they're out of touch with modern issues. Now, in this case, the bias is a lot more explicit because they're explicitly mentioning people over 60, and that's an ageist bias. But in the case of job hiring, it could also be very implicit, which is a lot more passive in comparison to explicit bias, where men are preferred for this position, which essentially implies that they're favoring male applicants, but then they're not explicitly mentioning that there is a gender bias. So now when we look at, for the purpose of this presentation, let's focus on healthcare bias. In this case, healthcare bias, when we're talking about explicit bias, it could be something similar to the previous examples when we are particularly talking about the person's racial or cultural, when we're particularly pointing out the racial or cultural beliefs of that particular individual, then that is explicit bias. Such as in this case, they mentioned that the patient, a 45-year-old Asian male, is unlikely to comply with the prescribed treatment due to cultural beliefs. Now, these kind of biases occur in the healthcare sector quite frequently. But then when we think about it, it could have really huge consequences. And these consequences could be in the following 3 ways. Either it could lead to poor treatment, or it could lead to inaccurate diagnosis or delays in diagnosis. So this allows me to very smoothly segue into one of the projects that were a part of the Uncovering Bias in Language Models project. Now, I, as a Vector intern, even though I was working as a project management, I got the opportunity to also collaborate within a team that was participating in the ART project. And this team were focused on public health and fairness evaluation on clinical notes. Now, one thing that I would like to mention was that in the end, the work that we had done, our paper ended up getting our project ended up getting accepted for an oral presentation at Casper for 2024. Now, what exactly is public health and fairness evaluation on clinical notes? The main aim of this project was to evaluate existing disparities and biases in machine learning prediction across different demographics, paving the way for more equitable healthcare practices, ultimately improving patient outcomes. Now, in order to achieve this particular aim, we wanted to focus on a certain problem, and this problem was hospital readmission rates, predicting hospital readmission rates within a 30-day period. why did we want to focus on this particular problem? Because firstly, it acts as a crucial indicator of healthcare quality and care continuity. Secondly, despite advancements in machine learning, there still remains a pressing concern regarding potential biases in predicting readmission rates within such models. So the motivation of our project was essentially to enhance the accuracy of machine learning models in predicting hospital readmission rates, while also ensuring that there was fairness across all the groups based on race, age, and gender. So given the motivation and aim, we were able to frame the research question, which was, to what extent do classification models in machine learning accurately predict hospital readmission rates based on clinical notes? And if such predictions showcase any sort of disparities across different demographics. Now, for the purpose of this project, we focus on racial demographics. So how exactly did we go about this project? Speaking about the methodology or the workflow, we first started with the data preparation. So the data that was employed for this project was the Mimic4, and we prepared the data in such a way that it was able to cater towards the specific focus on predicting hospital readmission rates. The way how we did this was we considered two different tables, the admissions and the discharge table, and then combined it to form the readmissions table. Now, within this readmissions table, we added two different columns, which was race grouped and output label. The race grouped was essentially all the races, being all the different races within our admissions table was essentially grouped into six major race groups, which was Asian, Hispanic, Latino, Native American, white, Black, and others. The output label, on the other hand, was another column that indicated whether a patient would get admitted or not, would get readmitted or not. And this would be values of 0 and 1. Now, moving on, we then started our modeling, which was done by leveraging classification models, which included two baseline models, XGBoost classifier and the logistic regression model. And then this was followed by a clinical BERT classifier to predict the readmission rate using clinical notes. Now, when we looked at the implementation of these models, the logistic regression, now before we began to implement such models, we looked at our clinical notes and we started, we had to pre-process the notes. So this involved cleaning up the data. And so this involved removing extra spaces, additional characters, removing stop words, and so on. And then after that, we started vectorizing. We essentially created vector embeddings of the clinical notes, and this was done using GenSim's doc-to-vec train model in the case of logistic regression. In the case of XGBoost, we used the TF-IDF vectorizer model. Now, both of them led to an average accuracy score, which was around 80% for both of the baseline models. Then the third one, which was the clinical BERT classifier, involved tokenizing the clinical notes text. And then we had to modify the classifier head in order to include additional features, such as race grouped, along with the clinical notes. Then we leveraged the pre-trained BERT model for sequence classification and performed batch-wise inference for predictions compared with the true labels. Now, unfortunately, in this case, the accuracy seemed to be very low, which was around 52%, but we can get more into that during the later part of the presentation. Once we were done with implementing the models, we wanted to evaluate the fairness of our models prediction across different demographic groups. And this was done by basically figuring out what the prediction distribution looked like across different demographic groups that included white, Black, Asian, Hispanic, Native, Indigenous, and others. Now, in the case of logistic regression, we can see that even though the accuracy was relatively higher than the rest, we can see that most of the time it tends to predict that the patient does not get readmitted. In the case of XGBoost classifier, it seems to do a much better job at predicting whether the patient gets readmitted or not. But there still is, but it does not perform as ideally as we would want it to. And then moving on to the BERT classifier, this does a better job at predicting whether the patient was readmitted or not. However, across all the different demographic groups, the accuracy of this model still seems to be pretty low in comparison to the baseline models. Now, moving on, once we were done with evaluating the fairness of our model's predictions, we decided to perform a fairness and bias audit on our predictions. And this was done using a tool which was referred to as Aequitas. This particular tool allowed us to generate a fairness report, which explored racial disparities in our model's predictions. The way how we were able to explore these racial disparities was using a certain metric, which is referred to as PPR, or the predicted positive rate. Now, the predicted positive rate is a metric that is used to measure the differences in the predicted positive outcomes amongst all the different groups or categories. And this PPR metric allows us to highlight potential biases or inequities in our predictive models. Now, in this case, we can see that the PPR for all the non-white groups is significantly lower in comparison to the white group. For example, for Black, it's 0.26, for Hispanic Latin, it is 0.08, and for Asian, it's 0.04. So this further emphasizes the importance of addressing racial disparities in healthcare, because we can clearly see that there's a substantial variation in readmission predictions across the racial demographics. Now, this was the case for our baseline models. But then when we move on to our BERT classifier model, we can see that the PPR values are still very similar to the baseline models, which essentially indicates that there was still a significant variation in readmission predictions across racial demographics. Then moving on, once we were done with evaluating and performing a fairness and bias audit on our predictive models, we can essentially come to the conclusion that we were able to identify disparities in readmission rates across different demographics. And this essentially confirms the fact that there is potential bias in machine learning models. However, we need to acknowledge that there were some limitations as we went through the project. First, data limitation. So utilization of Mimic for data, since the Mimic for data only gets the data from one hospital, it may limit the generalizability of the model to other healthcare settings with different patient population and different practices. Another limitation was the BERT classifier performance, which is the performance of the BERT classifier may have been influenced by the quality and the quantity of the input data. Additionally, we can also see that the readmission labels, readmission labels for all the different demographic groups were quite imbalanced. And we can see that most of the time the patients were not readmitted. And this is the reason why the quality of the data could have been impacted. Now, the future work for the project for this project could be possibly exploring other medical language models. Then another thing would be refining the model or improving the model performance by perhaps summarizing the clinical notes before you add it as an input to the model. Then thirdly, we could also focus on data enhancement. Now, I did mention that there was an imbalance of our class labels, so maybe rebalancing the class labels or maybe taking into account the demographics around the hospital could allow us to improve the model performance. Now, even though this project had its limitations, I would say that the overall impact of this project is huge because the overall future impact of this project can be huge. And this can be in different ways. First and foremost, through this project, we were to some extent able to identify, understand, and quantify the extent of bias. In this case, that would be racial bias. Then secondly, it also gave us some hope or some motivation to start implementing strategies to mitigate that bias or to implement fairness measures. Thirdly, it also allows us to move forward towards the direction of building trust and reliability in machine learning models, as well as promoting accountability and responsible AI development. Lastly, it also allows us to ensure fairness and equal treatment or move towards that direction that would allow us to develop AI models that would ensure fairness and equal treatment, especially in the healthcare sector. Now, as I'm done with this, as this particular presentation has come to an end, I would still like to mention that even though I was a part of this particular project, this particular team, I also had the opportunity to work as a project manager throughout the last stages of the development cycle of the ARC project. And this allowed me to gain a lot of exposure to the overall development cycle. And at the same time, I was also able to gain a lot of insights about the innovative solutions that were developed through the combined efforts of researchers from academia and industry. Thirdly, I was also able to gain a lot of extensive knowledge when it comes to applying agile methodology, when it came to delegating my project management and technical tasks to efficiently collaborate amongst my team members. But that's pretty much it. And I'd be happy to take any questions if there are any.
Yeah, go for it. Did you test from other subgroups, for example, the other demographic features like gender or age?
Yes, so this was something that we planned to do in the beginning, but then because of the limitation of because of time and a lot of other within the group I think it was mostly like something that we planned to do in the beginning. However, due to since the project had to come to an end, we were not really able to explore that particular aspect.
Okay.
So we just stuck to racial demographics.
Can you talk a little bit more about what comes next? I'm interested in kind of the implementation space and how hospitals and health institutions and governments can learn from this. You talked a little bit about kind of future research where you think the implications are. Talk to me about like what practical takeaways that you think Vector could even go loudly to stakeholders with from these findings.
I think these findings tend to, I think overall, what we can take from these findings would essentially being a lot more mindful when it comes to implementing machine learning models in healthcare data. Because first of all, we like in our particular project, we faced that there was, when we were dealing with mimic 4 data, it was not very generalizable. And along with that, the data itself was it was not balanced properly. So the data itself, and along with that, the data itself for certain groups, like for example, for the white group, there was a lot more data points than there were for other non-white groups. So when I think one of the key takeaways from this would be just throughout the entire development cycle of any sort of AI model within healthcare, keeping in mind that these certain factors can lead to producing bias in the model is possibly what I would take away from from my experience in this project.
And you talked a little bit about how to mitigate that with different models and testing what they're good at, what they're not. Do you think there's future kind of research or work to be done in terms of we've kind of identified this as a problem, the solutions to addressing this in terms of techniques and how to approach this challenge? Questions?
I think.
Yeah,
sorry, could you rephrase the question?
The question is there future work to be done in trying to figure out how to address this problem?
Sorry. I think yes. One possible way of addressing this problem would first and foremost looking at the data, balancing, like looking at how comprehensive the data is, and then secondly, it would be also looking into. I think the answer would be very similar to the previous answer that I had. It would be looking through every single development cycle in when you're deploying a machine learning model, and just making sure that when you're looking at the data, you have a good balance of all the different groups. And then when you're also building the model, you're able to make sure that the model does not develop any sort of like when you're able to build that model and deploy it, right before deploying it, you're essentially testing it whether the model has some sort of biases or anything of that sort when it's predicting on any sort, like a new data set or anything of that sort. But yeah, I think personally, I don't think I have a lot of experience in that end, so I won't elaborate a lot on that. But I do think that it should be something to keep in mind for all the researchers throughout the different stages of deployment.